we have talked about the static loading. Now we need to talk about the variable loading case. All right, I start from actually a still constant stress situation, which is a rotating shaft. Okay, on this rotating shaft and two ends, we have a pair of tensile forces. All right, under this tensile forces, every moment, the stress should be the same, even at this point P. No matter which location point P should be at, the stress is constant. Okay, so force divided by area. If I apply a pair of bending moment, okay, even a constant bending moment pair, so it doesn't change as a function of time, it doesn't change the location, it doesn't change the amplitude, the stress will be different. Okay, we still look at the stress at the point P. It still has this stress caused by force, but it has additional term that is due to bending. And this bending stress is a function of y, and y is the location of P, and y is a function of time. All right, it goes at the current moment, this bending stress is maximum tension, okay? But when it turns to the top, this becomes maximum compression, which is the negative side. So we can define the maximum and minimum of this stress variation. All right, so as you can see that this first part doesn't change. It still stays here. But the second term, all right, it goes to the tensile side, which is the plus side of this. All right, when P is at the bottom. All right, it reaches to the compression side, negative part of this, the second part. All right, when the P location changes to the top. All right, of course, when P location is at the neutral axis, and second term becomes 0. But here we only define the maximum and the minimum of these variable with this variable stress. Okay, we can define the amplitude of this stress variation. So of the stress variation, that actually is the maximum minus minimum divided by 2. Okay, by doing that, we cancel the constant term. We only have this variable part left. We can also define the mid-range. That is, we want to cancel out this changing term. All right. So what we can do is we can use maximum plus minimum and then divide by 2. And as a result, we cancel out this changing portion. All right. So we have the amplitude and mid-range defined. And by means of amplitude and mid-range, we can redefine the maximum and minimum, which becomes sigma, the stress mid-range plus minus the amplitude part. Okay, so this whole thing basically shows us the, this is the variable stress itself, the range of change from maximum to minimum, and what is the amplitude of the change, and what is the mid-range stress. We can use this information and plot the whole thing. That shows us this stress variation. All right, so this is the stress at the point P as a function of time. Okay, at the beginning, it starts at its maximum. That means both stresses are positive, all right, maximum. And then it changes as a function of time. Okay, it reaches to the minimum, and so on and so forth. It repeats itself. All right, such a stress that repeats itself as a function of time is called cyclic stress. And for this case, you can see that the physical meaning of this one is, of this diagram, is that the bending stress is on top of a constant tensile stress. All right, this bending stress changes completely like this, but the stress due to this uniaxial force becomes, it basically is a constant. All right, so the stress caused by the force defines the mid-range. So if the mid-range plus the amplitude of the change, we got the maximum. The mid-range plus minus the amplitude of change, we got the minimum. All right, so this diagram basically shows us the general situation of stress variation. We can also define 3 special cases. Okay, one is the completely reversed cycle. That means we do not have this constant force. All right, if we do not have this force, then we do not have this constant stress. All right, so then the stress amplitude, the stress cycle becomes completely reversed. The positive side and the negative side become equal. We can also have something called the released tension. That means that the minimum stress reaches 0. All the other things are just on the positive side. We can also have something called the released compression. That means the maximum stress reaches 0. All the other part stays at negative side. That's the end of this portion.